this video, I'm going to talk a little bit about how we're going to be measuring masses and volumes for this first lab and others in the future. So what you can see right now are these graduated cylinders. So we've got a 10 milliliter graduated cylinder. So you can see on here it tells you the 10, and then we've got 10, and then they've got the milliliter unit here. And so all of these numbers on here correspond to milliliters. And so the first line here is 1 milliliter, the second one's 2, 3, all the way up to 10. So this graduated cylinder can be used to measure anywhere from 1 mil to 10 mils. And then this larger one that I have here, this one, if you look up at the top, it says 100 milliliters. And so all of those numbers also correspond to milliliters. So this big line here corresponds to 10 mils, 20 mils, 30, 40, 50, 60, and so on, all the way up to 100. So you can measure anything actually from 1 mil all the way to, 5 mils all the way up to 100. So the lowest line on this one gives you a 5 mil mark, whereas the lowest line on the 10 mil is at the 1 mil. They don't have measurement markings below that. So that's what we can measure with those. But when you take measurements in the lab, it's important that you know how to properly read a scale and not just get the numbers like 1, 2, 3, 4, and so on, but know how many decimal places you need to report in these values, or if there should be decimal places. It would all depend on the measurement markings on that device. And so we're going to look at these two because we're going to be using them a lot. So the 10 mil graduated cylinder, if we look close at that one, what you will see is that each of those between, the 1 and the 2, the 2 and the 3, 3 and 4, and so on, they're split up into 10 segments. Okay, so the major tick marks are the ones, where the 1 is, where the 2 is, the 3, and so on. But then those ones in between that don't have numbers associated or written next to them, those are the minor tick marks on the scale. And so that splits those between 2 and 3 into 10, or between 3 and 4 into 10. And so that's actually giving us a decimal place. And so if we go, say, 2 lines past the 3, and so if we go right up to here, 2 lines past the 3, that would actually be 3.2 milliliters. Or if we go to the third line, it'd be 3.3, and so on. So the tick marks on this 10 mil grad cylinder are telling us about 0.1 mils. But we need to estimate one more digit. So when you use any kind of measuring device that is an analog device, so something you're reading off of a scale, you should always be estimating one digit past what that scale tells you. So we need to estimate a second decimal place whenever we use this 10 mil graduated cylinder. So what that second decimal place is going to do is going to tell us, does our measurement fall right on a mark? So are we at maybe right at the 5 mils? Or are we somewhere between the 5 mils and the first tick mark? And so if you're right on one of those tick marks, then your second decimal place for this is going to be a 0. If you're somewhere between 2 of the tick marks, say you're halfway between 2 of them, then you're going to use a 5 for that second decimal place. If you're just maybe a hair past a tick mark, then maybe you're going to use a 1 for your second decimal place. That estimated decimal place is, up to some of your own judgment. So some people may come up with a little bit different value for that estimated digit, but should be close. But the tick marks are a definite reading where the measurement is, on a tick mark or between. So remember, the 10 mil grad cylinder, we're always going to take measurements with 2 decimal places. Even if we're right on a major tick mark, if we're right at the 3, then we're going to write down 3.00 milliliters. Okay, you can't drop those, otherwise you're miscommunicating the precision of the measurement. Okay, so let's look at the 100 mil graduated cylinder. This one's a little bit different. So realize that those major tick marks, instead of being 1, 2, 3, all the way up to 10, it's 10, 20, 30, and so on. But like the 10 mil grad cylinder, between each of those major tick marks, you do have it split into 10 segments. So that's the same. But those aren't 0.1, because from 10 to 20, if 10 units between that are ones, not 0.1. Because if it was 10.1, 10.2, and so on, then this would be 11, not 20. Okay, so the minor tick marks on our 100 mil grad cylinder are actually the ones place. Okay, so if you are right on that 10, it's 10 mils, but if you're 1 tick mark past, you're at 11 mils. If you're 2 tick marks past, you're at 12 mils, and so on. So that means the tick marks, the actual graduations on that, are going to give us just a whole number. But we need to estimate one more digit. So we need to estimate a decimal place. And so it's going to be similar to, the 10 mil grad cylinder, where that estimated digit is going to tell us, did our measurement fall directly on a tick mark? If so, our, decimal place in this case, which would be the first decimal place, would just be a 0. Okay, if it falls between 2 tick marks, then you're going to have something like 0.1 or 0.2 or 0.3, depending on where exactly between those tick marks it falls. So those are 2 tools that we use a lot to measure volume in lab. There are other ways, pipettes. You could use beakers. They're not great for measuring volume because they're a very rough estimate, but I guess you could. So there are other tools, but these are ones that we use a lot, and it's very important that you read those scales properly. Now, I also said we're going to be measuring masses. Mass is going to be much easier for us to measure because we conveniently have a digital balance. Okay, so we actually have several in the lab, but this is the one that I will be using. And what you should notice here is on that screen you see 0.00. That's because it's been zeroed or tared. And there's nothing on that scale. Once I put something on there, that number is going to obviously change. But it shows right now 0.00, showing you that the readings are going to have 2 decimal places. Okay, so this particular balance gives us a precision to the second decimal place, similar to the 10 mil graduated cylinder. The measuring precision is to the second decimal place. And so we don't have to do an estimate, or you wouldn't do an estimate for this type of instrument because it gives you a digital readout. So that digital readout is already doing the estimation for you. Okay, so that second decimal place is actually, not exact. Okay, and if I picked up this balance and looked on the back or the bottom, somewhere it tells us exactly what the error is. Or actually it's right here. Usually it's hidden, but here we go. So it says this balance maxes out at 400 grams and the deviation is 0.01 grams. And so that's the error. That last digit, when it gives us, say, a 1 at the end, then it actually could be a 1, could be a 0, could be a 2. Okay, and so that's the error in that, or the possible deviation in those measurements. So those are the tools we're going to be using a lot in this class, and so you need to know how to utilize those properly. Make sure your 10 mil grad cylinder, you're writing down 2 decimal places. Your 100 mil grad cylinder measurements should be to 1 decimal place, and all of our masses will be to 2 decimal places because we will use this balance or a similar one.